All right, welcome back. We're on day 6 of ACT Prep Unit 2, Pre-Algebra 2 topics. Today we're going to talk about probability. Excuse me. The probability of an event is the likelihood that it will occur. If an event will never occur, the probability is 0. If an event will always occur, the probability is 1. All other probabilities fall between 0 and 1. Use a fraction to write the probability of an event. Okay, remember this. Your probabilities have to be between 0 and 1. Okay, you can't have a probability of 5. It's got to be between 0 and 1 because 0 means that the event will never happen. 1 means that it's for sure to happen. So everything else has to be between never and for sure, or never and always. Okay, so you can't have a probability less than 0 and you can't have a probability greater than 1. And the way you calculate your probability, the probability of any event happening is, like they said, a fraction. The top is the number of favorable outcomes, in other words, how many ways you can win, over the total number of possible outcomes. Alright, so it says, think of rolling a single fair die. What is the probability of rolling a 3? Well, when you roll a die, what could happen? It could land on a 1, a 2, a 3, a 4, a 5, or a 6. They want to know the probability of rolling a 3, which means 3 is a winner. Everything else are losers. So there's one way to win out of 6 possibilities. So the probability of rolling a 3 is 1/6. Done. What is the probability of rolling an even number? Well, that would make 2 a winner, 4 a winner, and 6 a winner. So there's 3 ways to get an even number out of 6. So the probability of rolling an even number is 1/2, because I reduced that. Okay? Alright, what is the probability of rolling a 7? Well, again, your possibilities on a die is it comes up a 1, a 2, a 3, a 4, a 5, a 6, or a 6. There's only 6 sides. So the probability of rolling a 7, nope, loser, 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 loser. There's the probability of rolling a 7. There's no chances of rolling a 7 out of 6. 0 divided by anything is 0, which means this event can never happen. It's impossible to happen. There's no 7 on the die. And then 4 says, what is the probability of rolling a number less than 10? Well, again, 1, 2, 3, 4, 5, 6. Less than 10 is a winner. Winner, 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 winner. So the probability of rolling less than 10 is 6 out of 6, which is 1, which means this is certain to occur. It has to occur because all the numbers on a die are less than 10. Sorry for that. Alright, independent and dependent events. Independent events is when the outcome of one event does not affect the probability of the other event. So, for example, you have a standard deck of 52 cards. The probability of picking the King of Hearts is 1 out of 52 because there's one King of Hearts. That's the winner. There's 52 possibilities. You pick a card without looking and replace it in the deck, so you put it back. That means that there's still 52 cards in the deck. So the probability of picking the King of Hearts next time is still 1 out of 52. One card picked and replaced, followed by picking another card, are independent events. Whatever you picked on the first event, when you put it back, that means it has no effect on what you will draw next, because you put it back. An example of dependent, that's when the outcome of one event does affect the probability of the other event. So let's say you have a standard deck of 52 cards. The probability of picking the King of Hearts is 1 out of 52, just like we talked about before. But this time you pick a card without looking, which wasn't the King of Hearts, and you don't put it back. So when you go to draw your next card, since it wasn't the King of Hearts, you still have one chance to get it, but now there's only 51 cards in the deck instead of 52. Okay? So now your outcomes are affected because you have less cards to pick from. So a card picked and not replaced, followed by picking another card, it just depends. It depends on what you pulled out the first time. Okay, those are dependent events. Alright, you try this one. Hit pause. Come back when you're ready. And hopefully you got 3/8. In a jar, you've got 3 blue marbles, 5 red marbles, and you reach into which gives you a total of 8 marbles. It says you reach into the jar and pick out a marble without looking. What is the probability that you will pick out a blue marble? Well, blues are winners, so there's 3 winners in there out of a total of 8. There's my probability. Okay, try this one, hit pause, come back when you're ready. And hopefully you got 3 out of 26. It says, what is the probability of choosing without looking a red face card from a regular deck of cards? And they're telling you their definition of a face card is a jack, queen, or king, because a lot of people consider the ace face card, but they're saying no. So you have in a deck, you have aces, 1s, 2s, 3s, 4s, 5s, 6s, 7s, 8s, 9s, 10s, and then your face cards, jacks, queens, and kings. There's 4 of everything. There's 4 aces, 4 1s, 4 2s, 4 3s, 4 4s, 4 5s, 4 6s, 4 7s, 4 8s, 4 9s, 4 10s, 4 jacks, 4 queens, 4 kings. Okay, so it says, without looking, they want a red face card. By the way, there are 4 aces, 2 red, 2 black, 2 red, 2 black, 2, because you have hearts, diamonds, those are red cards. You have clubs and spades, those are black cards. So, to pull a red face card, well, there's only 2 red jacks and 2 red queens and 2 red kings. So that would be 6 ways to win out of 52, which reduces down to 3 out of 26. Okay. All right, so let's practice a little bit. It says you have a fair penny. When you flip a penny, it could land on heads or it could land on tails. So what is the probability of flipping a tail? Well, that would make this the winner. That's 1 winner out of 2 possibilities. What is the probability of flipping a head? Well, there's only 1 head, so that's 1 out of 2 possibilities. What is the probability of flipping a head or a tail? When you have an or, that's an adding. So you take the probability of a head plus the probability of a tail. Well, the probability of flipping a head is a half. The probability of flipping a tail is a half, which makes it 1. Those are the only 2 things that are happening. So again, this is certain. One of them is going to come up. It's certain to happen. 4. You flip the penny 10 times and get 10 heads. What is the probability of getting a head on the next flip? A lot of people assume that, well, that penny for some reason keeps wanting to land on heads. So since it's landed on heads so much, it's going to land on heads again, or vice versa. Well, it can't land on heads again. It's landed on heads too many times. That coin doesn't know what happened the last 10 times. Whatever you did the first time will not affect what happens the second time. They're completely, each flip is independent of the last. Just because you flip heads once doesn't mean that increases the chances of getting heads again. So it's still, what's the probability of getting heads on the next flip? There's 1 head out of heads or tails. So it's still going to be 1/2. Okay, you have 6 same size balls, numbered 1, 2, 4, 5, 7, and 8 in a box. You pick one without looking. What's the probability of picking for 5 and 8? 8's the winner, so there's 1 way to win out of 1, 2, 3, 4, 5, 6 numbers. Okay, and we should be more professional. The probability of selecting an 8 is 1/6. 6, they want the probability of picking an even number. Well, that would make 2 and 4 and 8 winners, because those are the even numbers. So there's 3 of those out of 6, which reduces down to 1/2. A number greater than 6, so anything bigger than 6 is a winner. That would be 7 and 8. So the probability of a number greater than 6 would be 2 out of 6, which reduces down to 1/3. Okay, the probability of the number being divisible by 6. 1 is not divisible by 6, 2 is not divisible by 6, 4 is not divisible by 6, 5 is not divisible, 7 is not divisible, none of them. So there's no winners out of 6 possibilities, which is 0, which means it can't happen. It's impossible. Okay, and 9 says a multiple of 4. Well, 4 is a multiple of itself, and 8 is a multiple of 4. In other words, what numbers would 4 go into evenly? 4 would go into 4, and 4 would go into 8. So the probability of getting a multiple of 4 is 2 out of 6, which reduces down to 1/3. Okay? Number 10, you have a standard deck of 52 cards. What is the probability of picking a 7, a red card, a heart, a not? Okay, so let's look at a deck of cards. As I said earlier, you have 4 aces, 4 ones, 2 threes, 4s, 5, 6, 7, 8, 9, 10, jack, queen, king. There's 4 of each of these. These are just things you should just memorize about a deck of cards. It's funny, young people don't play cards as much because we have so much technology. Cards are like old school. So you need to learn about a deck of cards because they're famous for probability questions. So you have 4 of each of these cards. You also have 13 hearts, 13 diamonds, I'm drawing pictures, 13 clubs, and 13 spades. You have then 26 red cards, 26 black cards. Okay? Alright, so that should be about all you need to know about the cards. Alright, so what is the probability of picking a 7? So probability of a 7, well, there's 4 7s, so there's 4 ways to win out of 52, and that reduces down to 1/13. A red card, well, we said there's 26 red cards, so the probability of picking red, there's 26 ways to win out of 52, which reduces down to half the deck. And makes sense, half the deck is red. Okay, a heart, there's 13 hearts, so the probability of selecting a heart is 13 ways to win out of 52, which reduces down to 1/4. The probability of non-face card. Okay, a non-face card would be all of these. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 fours. Ooh. 11 fours would be 44 out of 52. Reduce that down. By 2 is 22, by 2 is 26, by 2 again is 11 over 13. Okay, a 2, a 3, or a 4. You win on 2s, that's 4 ways to win. You win on 3s, that's 4 more ways to win. And you win if it's a 4, so that's 4 more ways to win. 4 plus 4 plus 4 is 12, so the probability of 2, 3, or 4 is 12 out of 52, which reduces down to 3 out of 13. Okay. 15, a 9, or a 10. You win on 9s, there's 4 of those. You win on 10, so the probability of a 9 or 10 is going to be 8 out of 52, which reduces down to 2/13. And then 16 says a jack, a queen, or a king. Well, there's 4 jacks, 4 queens, 4 kings, so the probability of a jack, queen, or king is again 12 out of 52, which reduces down to 3/13. Okay? Alright. You pick a 7 of clubs and don't replace it. That means there's only 3 7s left now, because you have a 7 out, and there's only 12 clubs left. Okay? So, you take the 7 of clubs out, and that means there's only 51 cards left in the deck when you draw again. So you pick the 7, you don't replace it. What's the probability of the next pick being a 6 of clubs? Well, there still is 1 6 of clubs in the deck, so there's one way to get it, but now there's only 51 cards in the deck because the 7 of clubs is out. So if you pick the 7 of clubs and you don't replace it, what's the probability of picking the 7 of clubs? Well, if the 7 of clubs is out, there's no more 7 of clubs in the deck out of 51, which is 0. It can't happen. If you took the 7 of clubs out, you can't draw the 7 of clubs. Okay, a 7, well now there's not, we don't care about the club, but you took a 7 out of the deck, which means there's only 3 left in the deck out of 51. And that reduces down to 1 out of 117. A club. There are only 12 clubs left because you took one of the 13 clubs out, so there's only 12 ways left to win out of 51, not 52. Sorry, because we don't have 52 in the, which reduces down to 4/17. Okay? Alright, you try this one, hit pause, come back when you're ready. And hopefully you got 3/10. In a drawer, you have 3 brown socks, 2 blue socks, 5 red socks. You pick a sock without looking. What is the probability of choosing a brown sock? Well, there's 3 ways to choose brown. Out of 3 plus 2 plus 5 is 10. So 3/10. Try this one, hit pause, come back when you're ready. And hopefully you got a third. It says, what is the probability of rolling a 1 or a 5 with a single 6-sided die? Well, you can get a 1, a 2, a 3, a 4, a 5, or a 6. You win if it's a 1 or a 5. So there's 2 ways to win out of 6 possibilities, which reduces down to 1/3. From a regular deck of 52 cards, what is the probability of choosing a card that is not an ace or a face card, but that is divisible by 2? So, I'm going to set myself up here again. Okay, aces, 1s, 2s. Aces, 2s. I don't have aces and 1s. Aces, 2s. Oh, I screwed up on one of those. I think on that one of those I put 1s. Oops. Check my work on one of those. I think it was the one where it said, what's the probability of, oh darn it, check me. I think I put aces, 1s, 2s. Aces are the ones. Sorry. Anyway, aces, 2s, 3s, 4s, 5, 6, 7, 8, 9, 10, jack, queen, king. Yeah, it was the one with that. What's the probability of not picking a face card? I said it was 44. It should actually only be 40 out of 52. Sorry, I'm a schmo. There are no 1s in the deck. Fix that one. That's the only one I screwed up. Okay, so anyway, there's 4 of everything. 4, 4, 4 of these, 4 of these, 4 of these, 4 of these, 4 7s, 4 8s, 4 9s, 4 10s, 4 jacks, 4 queens, 4 kings. So what is the probability of choosing a card that is not an ace? So those are out. Those are losers. Or a face card. So those are out. Those are losers. But that is divisible by 2. So your winners are whatever's left, the ones that are divisible by 2. 2 is divisible by 2, 4, 6, 8, and 10. So that's 1, 2, 3, 4, 5 4s, which is 20 out of 52. And that reduces down to 5 out of 13. Did I give you a chance to work that one? Alright, try this one, hit pause, come back when you're ready. And hopefully you got 1/5. It says if a king and a jack are removed from a regular deck, so we're just talking about face cards. So there was 4 jacks, 4 queens, 4 kings. But you took a king out, which means there's only 3 kings, and you took a jack out, which means there's only 3 jacks. Okay, so you got a king is out, a jack is out, so what is the probability of picking a face card? Well, that leaves 3 and 3 is 6 and 4, 10 ways to win. But now you took 2 cards out, so there's not 52 cards in the deck, there's only 50 cards in the deck, which reduces down to 1/5. Alright, try this one, hit pause, come back when you're ready. And hopefully you got 1/4. So you have 20 colored pencils in a box. 4 red, 5 green, 10 blue, 1 black. You pick a pencil without looking. What is the sum, which means I'm adding up probabilities of picking a red and the probability of picking a black? Well, my probability for picking red is 4 out of 10, 15, 20. Sum means add, and the probability of picking black is 1 over 20, which gives me 5 out of 20, which reduces down to 1/4. All right, and we are done with today, so I will see you next time for day 7.